Hi and a very good day. I've been to Dr. Rosita and Dr. Shazaruddin. Today my group going to present our energy balance design project. Our company's name is Ideaqo Sdn Berhad. My name is Matisha Nalaki Gunarayu, matrix number 195980.
My name is Farah Hanam Shafi'i. I'm matric number 198514.
My name is Lee. My matric number is 19400.
My name is Arhanis Binti Muhammad. My matric number 198743.
Okay, the feed rate given is methanol and 100 ton per month, and this is the block flow diagram, the overall block flow diagram. This is the process selection route, which starting from heater 1 to pump to reactor to cooler 1 to distillation column and to pressure reductor 1 to heater 2 to detail reactor to cooler 2 to compressor to demethanizer to pressure reductor 2 to separator to pressure reductor 3 and finally fractionation to produce 99.9% ethylene. And the feed given is 100 ton per month methanol, and we converted it to kilomole per hour. We get 4.2568 kilomole per hour, and finally the product we get is C2H4, which is ethylene, ethane, propylene, and propane.
And for the heater 1, the input flow rate is 4.2568 kilomole per hour, and temperature is 389.15 Kelvin. Pressure is 1.145, and output is also 4.2568 kilomole per hour, and temperature is 523.15 Kelvin, and pressure is 10 bar. The Q is 11.2471 kilowatt. And for the pump, the input from the heater is 4.2568 kilomole per hour. Temperature is 500 and to 3.15 Kelvin, and for pressure is 10 bars. For output flow rate is 4.2568 kilomole per hour, and temperature is 5 to 3.15 Kelvin, and the pressure is 15.5 bar, and the work shift is 0.0158 kilowatts. And for the reactor, input from the pump is 4.2568 kilomole per hour. Temperature is 5 to 3.15 Kelvin. Pressure is 15.5 bar. And output is 4.256 kilomole per hour. Temperature is 523.15 Kelvin. Pressure is 15.5 bar. And Q is negative 1.3064 kilowatt.
Okay, so for the reactor, so the inlet is 4.25cc kilomole per hour with temperature of 523.15 Kelvin and pressure of 15.5 bar, and the same outlet with the temperature slightly decreased temperature, which is 373.15 Kelvin with pressure of 15.5 bar, and we release negative 43.478 kilowatt per of energy. Okay, so from the cooler, go to the distillation column. So distillation column is the same, 4.25cc kilomole per hour with temperature of 373.15 Kelvin and pressure of 15.5 bar. And for the distillate is 1.6208 kilomole per hour with temperature of 381.02 Kelvin and pressure of 10.4 bar. And for the bottom is 2.636 kilomole per hour with temperature of 169.5 Kelvin and 7.4 bar pressure. And this unit will produce 11.4860 kilowatt of energy. Okay, so for the pressure reductor, the same inlet with the same outlet temperature and pressure from the distillate will produce 1.6208 kilomole per hour with temperature of 373.35 Kelvin and 0.5 bar pressure. So this unit will release 0.3905 kilowatt of energy. Okay, so from pressure reductor 1, the same inlet with the same temperature pressure of outlet from pressure reductor 1 will produce the same flow rate with temperature of 73.15 Kelvin and 1.2 bar pressure, and this unit will release 1.7142 kilowatt of energy.
The reactor from heater, the output is 1.6208 kilo per hour, and also then the temperature heat is 7 to 3.5 and pressure is 1.2 bar. The Q released by the reactor is 71.2093 kilowatt, and the output is 1.614 kmol per hour, then enter the cooler. From the cooler, from the reactor, the input is 1.214 kmol per hour. Also same for the outlet, the cooler. The pressure input and output is the same, but the temperature for the input is 722 to 3.15 Kelvin. The temperature outlet is 290.98 Kelvin. Q produced by cooler is negative 15.9 kilowatt. Then from the cooler enter to the compressor 1. From compressor 1, the input and output is also the same. The temperature output input is 290.98 Kelvin, pressure 1.2 bar. The pressure for the outlet is 200 Kelvin, pressure is 17 bar. Workshop produced by the compressor is 2.1061 kilowatt. From the cooler, from the compressor, then enter to immunizer. The immunizer, the input from the compressor, the temperature is same, 200 Kelvin, pressure is 70 bar. The immunizer have 3 streams. First stream 0.1615 kmol per hour, second 0.89119 kmol per hour, and third stream 0.1136 kmol per hour. The pressure, the tree is different and the temperature is different. Then from the immunizer, enter to pressure reactor 2.
From the demethanizer, the flow rate is 0.8919 kmol per hour with a temperature 257.73 Kelvin and pressure 15 bar. Enter to pressure reductor 2, and the output is 0.8919 kmol per hour with a temperature 237.38 Kelvin with a pressure 11.99688 bar. And you will enter to separator, and this pressure reductor 2 is to reduce the pressure. So it will enter from the separator, not from the methanizer. With the flow rate 0.8919 kmol per hour with a temperature 237.38 Kelvin, pressure 11.99688 bar, and the top product is 0.7437 kmol per hour, and the temperature is 229.47 Kelvin, and the pressure is 11.99688 bar. And the bottom product is 0.1481 kmol per hour with a temperature 245.30 Kelvin, pressure 11.99688 bar. And the function of separator is to separate gas and liquid, and the energy release is negative 0.5858 kilowatt. So from the separator, it will enter to pressure reductor 3 with a flow rate of 0.7437 kmol per hour with a temperature 229.47 Kelvin and pressure 11.99688 bar. And the output will be the same as 0.7437 kmol per hour with a temperature 161.84 Kelvin and pressure 1.00312 bar, and it will enter to fractionation, and the work shaft is negative 4.4257 kilowatt. From pressure reductor 3, it will enter 0.7437 kmol per hour with a temperature 176.67 Kelvin and pressure 1.00312 bar, and the top product with a flow rate of 0.7384 kmol per hour with a temperature 169.33 Kelvin and pressure 1.00312 bar. And here we will produce ethylene with a purity of 99.99%. And the bottom product with the flow rate 0.053 kmol per hour and temperature 154.35 Kelvin and pressure 1.00312 bar is produced. And the energy release is negative 2.766 kilowatt. And the function of fractionation 1 is to increase the purity of ethylene.
Okay, so we move on to the costing estimation. So for the feed is 1,200,000 kg per year. We will produce our product, our main product, which is ethylene, which is 18,528 kg per year. Okay, so for this is going to calculate the maximum profit. So we have to calculate the maximum selling price minus the minimum cost. So for the minimum cost is 2,099,323 ringgit. So for the maximum selling price for all of the product we sell is 2,586,930 ringgit 12 cents. So maximum of selling price minus the minimum costing, we'll have the maximum profit, which is 437,597 ringgit 86 cents. Okay, so for the costing, we have fixed capital cost, which is 32,089,284 ringgit ratio. Okay, this is for the fixed capital cost. Okay, so there's a unit cost, working capital cost, and variable cost. So the overall cost will have amount of 1,604,130,663 ringgit. Okay, for the cash flow, for the first 2 years, we don't get income. But on the start of the third year, we have a revenue, okay, which is the picture on this graph is because it is negative on the first 3 years, and after that we increase, then it's stable increase after that. Okay, for the next is world ethylene demand by region. So this is the demand of the ethylene based on our product that we want to sell.
And for the first reactor is produce the DME. For the second one, cooler is to reduce the temperature. Dissimulation column 1 is to increase the priority of DME. Distillation column 2 is to separate methanol, ethanol, and water to be recycled back to the reactor. DTO reactor is to produce hydrocarbon from the DME. For the demethylizer to remove methane and separate the desired product. For separator to separate gas and liquid composition. And fractionation to increase the priority of ethane. For compressor to increase the pressure, and for heater is to increase the temperature. For the pressure reductor to decrease the pressure.
In conclusion, by feeding 100 tons methanol per month, our company can produce 199.009 tons ethylene per year. Recommendation of future work. We need to reduce the units. We did not consider the waste treatment, so waste treatment should be handled carefully for environment safety. And our cost is very high. In the future, we need to recycle the liquid stream to reduce our cost. That's all from us. Thank you very much.